No, it is not okay to use a 60 amp breaker with 6-2 Romex. Here are the reasons why. Firstly, it will create code violations. Electrical codes such as the National Electrical Code specify the maximum amperage ratings for different wire sizes and types. Exceeding these ratings can lead to safety hazards and code violations. Secondly, it will cause overheating. When a wire carries more current than it is rated for, it overheats. This can damage the wire insulation, creating a fire hazard. Thirdly, it will cause reduced ampacity. Overheating can also reduce the ampacity or current carrying capacity of the wire over time, making it even more likely to overheat. Fourthly, it will affect circuit overload protection. Circuit breakers are designed to trip when the current exceeds a certain threshold, protecting the circuit from damage. Using a circuit breaker with a higher amperage rating than the wire can prevent the breaker from tripping when it should, increasing the risk of overheating and fire. There are consequences. Using a 60 amp breaker with 6-2 Romex could have serious consequences, including fire, damage to electrical equipment, and personal injury. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for safe electrical installations. It covers various aspects of electrical systems, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is updated every 3 years to incorporate new technologies and address emerging safety concerns. It is widely adopted in the United States and serves as a basis for many local and state electrical codes. Compliance with the NEC is essential for ensuring the safety of people and property from electrical hazards. Several articles within the NEC directly relate to conductor ampacity and overcurrent protection. For example, NEC Section 240.4 addresses the protection of conductors against overcurrent. This section specifies that conductors must be protected by overcurrent devices, such as circuit breakers or fuses, sized according to their ampacity. The ampacity of a conductor is the maximum current, in amps, that it can carry continuously under specific conditions of use without exceeding its temperature rating. NEC Table 310.15b16 provides ampacity ratings for various types of conductors based on their size, insulation type, and installation conditions. For example, 6-2 Romex, which typically uses type NM-B cable, has an ampacity of 55 amps when used in residential applications under normal conditions. This rating is based on the conductor's ability to dissipate heat without exceeding its insulation temperature limit, which is typically 90 degrees Celsius for type NM-B conductors. Exceeding the ampacity rating of a conductor can lead to several problems. One of the most significant concerns is overheating. When a conductor carries more current than it is designed for, its temperature rises. Excessive heat can damage the conductor's insulation, leading to short circuits, ground faults, and potentially fires. Overheating can also degrade the conductor's ampacity over time, making it more susceptible to failure. Furthermore, using an overcurrent device with a higher amperage rating than the conductor's ampacity can prevent the device from tripping in an overload condition. This means that the conductor could be subjected to excessive current for an extended period, increasing the risk of overheating and fire. In the case of 6-2 Romex, using a 60 amp breaker would violate NEC Section 240.4, which requires that conductors be protected by overcurrent devices sized no larger than their ampacity. A 6-2 Romex cable with an ampacity of 55 amps must be protected by a 55 amp or smaller breaker. Using a 60 amp breaker would allow the cable to carry more current than it is rated for, increasing the risk of overheating and fire. There are some limited exceptions to the rule that conductors must be protected by overcurrent devices sized no larger than their ampacity. For example, NEC Section 240.4b allows the next highest standard overcurrent device rating to be used in certain cases where the conductor ampacity does not correspond to a standard overcurrent device size. However, this exception is subject to several conditions and is not applicable in all situations. It is essential to consult the NEC and local electrical codes to determine whether this exception applies in a specific case. Another important consideration is the dating of conductors. The ampacity ratings in NEC Table 310.15b16 are based on specific conditions of use, such as the number of conductors in a raceway or cable, the ambient temperature, and the type of insulation. In some cases, it may be necessary to dare the ampacity of a conductor to account for these factors. For example, if multiple current-carrying conductors are installed in a raceway or cable, the ampacity of each conductor must be reduced to prevent overheating. The NEC provides tables and formulas for calculating dating factors based on the specific conditions of use. When dating conductors, it is essential to ensure that the overcurrent protection is sized appropriately to protect the dated ampacity of the conductors. In addition to the NEC, many local and state electrical codes also have requirements for conductor ampacity and overcurrent protection. These codes may be more stringent than the NEC in some cases, so it is essential to consult the local codes before installing any electrical wiring. It is also important to note that electrical codes are constantly evolving to address new technologies and emerging safety concerns. It is essential to stay up to date on the latest code requirements to ensure that electrical installations are safe and compliant. In summary, using a 60 amp breaker with 6-2 Romex is a violation of the NEC and can create a fire hazard. The ampacity of 6-2 Romex is typically 55 amps, and it must be protected by a 55 amp or smaller breaker. Exceeding the ampacity rating of a conductor can lead to overheating, insulation damage, and potentially fire. It is essential to consult the NEC and local electrical codes to ensure that conductors are properly sized and protected. Ignoring these guidelines can have serious consequences, including fire, property damage, and personal injury. Electrical safety should always be a top priority, and it is essential to follow all applicable codes and regulations when installing or modifying electrical wiring. If you are not familiar with electrical codes and practices, it is best to consult a qualified electrician. They can help ensure that your electrical system is safe and compliant. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before performing any electrical work. They can assess your specific situation and provide tailored recommendations based on your local codes and conditions. Understanding the principles of conductor ampacity and overcurrent protection is essential for anyone working with electrical systems. By following the NEC and local electrical codes, you can help ensure the safety of people and property from electrical hazards. Remember that electrical safety is a shared responsibility, and everyone should take steps to prevent electrical accidents. This includes using properly sized conductors and overcurrent devices, inspecting electrical wiring regularly, and avoiding overloading circuits. By working together, we can create a safer electrical environment for everyone. When selecting conductors for an electrical installation, it is essential to consider not only the ampacity but also other factors such as the voltage drop, the type of insulation, and the environmental conditions. Voltage drop is the reduction in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. To minimize voltage drop, it may be necessary to use a larger conductor size than would be required based on ampacity alone. The type of insulation used on a conductor can also affect its ampacity and its suitability for certain applications. Some types of insulation are more resistant to heat, moisture, and chemicals than others. The NEC specifies different insulation types for different applications based on the environmental conditions and the type of equipment being served. For example, conductors installed in wet locations must have moisture-resistant insulation. The environmental conditions in which a conductor is installed can also affect its ampacity. High ambient temperatures can reduce the ampacity of a conductor, while low ambient temperatures can increase it. The NEC provides tables and formulas for adjusting ampacity ratings based on ambient temperature. When selecting conductors, it is essential to consider all of these factors to ensure that the conductors are properly sized and suitable for the application. Using undersized conductors can lead to overheating, voltage drop, and equipment malfunction. Using oversized conductors can increase the cost of the installation without providing any significant benefit. In addition to selecting the right conductors, it is also important to install them properly. Conductors must be installed in accordance with the NEC and local electrical codes. This includes using proper wiring methods, supporting the conductors adequately, and protecting them from physical damage. Improperly installed conductors can create safety hazards and reduce the reliability of the electrical system. It is also important to maintain electrical wiring properly. This includes inspecting the wiring regularly for signs of damage or deterioration, tightening loose connections, and replacing damaged components. Neglecting electrical maintenance can lead to safety hazards and equipment failures. Electrical safety is a continuous process that requires attention to detail and a commitment to following best practices. By following the NEC and local electrical codes, and by maintaining electrical wiring properly, you can help ensure the safety and reliability of your electrical system. The concepts of ampacity, overcurrent protection, and voltage drop are fundamental to electrical engineering and are essential for anyone working with electrical systems. A thorough understanding of these concepts is necessary to design and install safe and efficient electrical systems. There are many resources available to help you learn more about electrical safety and electrical codes. These resources include textbooks, online courses, and training programs. It is also helpful to attend seminars and workshops on electrical safety to stay up to date on the latest code requirements and best practices. By investing in your knowledge and skills, you can become a valuable asset to the electrical industry and help ensure the safety of people and property from electrical hazards. Remember that electrical work can be dangerous, and it is essential to take precautions to protect yourself from electrical shock and other hazards. Always energize circuits before working on them, use appropriate personal protective equipment, and follow safe work practices. If you are not comfortable working on electrical systems, it is best to consult a qualified electrician. They can provide the expertise and experience necessary to complete the work safely and correctly. Electrical safety is a shared responsibility, and everyone should take steps to prevent electrical accidents. By following the NEC and local electrical codes, and by practicing safe work habits, we can create a safer electrical environment for everyone. In conclusion, when dealing with electrical wiring, it is crucial to adhere to established codes and guidelines for safety. Using a 60 amp breaker with 6-2 Romex is a clear violation of these codes and poses significant risks. The primary concern is the potential for overheating, which can damage the wire's insulation and create a fire hazard. The National Electrical Code, or NEC, specifies the maximum amperage ratings for different wire sizes and types, and exceeding these ratings can lead to dangerous situations. Circuit breakers are designed to protect circuits from overloads, but using a breaker with a higher amperage rating than the wire can handle defeats this purpose. This can prevent the breaker from tripping when it should, increasing the risk of overheating and fire. The consequences of using an improperly sized breaker can be severe, including fire, damage to electrical equipment, and personal injury. Therefore, it is essential to ensure that the breaker size matches the wire's ampacity rating to maintain a safe and reliable electrical system. Always consult with a qualified electrician to ensure that your electrical wiring meets all applicable codes and standards.